All right, so we're writing equations of parallel lines. So let's just get a few things out of the way. First of all, let's start with parallel lines. And we have a symbol for this. You know, in math, we love our symbols, right? So the symbol, I'll put it in parentheses for you. So whenever I want to use parallel or parallel lines, in I'm just going to put this. It's like having absolute value symbols right next to each other. Two of them. Very descriptive. Okay, so parallel lines are two or more lines that, how can we end that? How can we end that sentence? Yes. Never touch, never meet, never intersect. Ooh, I like that one. Okay, so you get the idea. That's one important fact. Let's write the other important fact that's really going to help us. The slopes of parallel lines, using my symbol already, are, how am I going to end this? The slopes of parallel lines are equivalent, equal, identical, however you want to say it. Okay. So the point is, if I have a line and I know the slope of that line, and I want a second line to be parallel, they both better have the same slope. Okay? So this is what we're going to run with today and use. On Friday, we'll learn an important fact about the slopes of perpendicular lines. And spoiler alert, they're not going to be equal. So perpendicular lines are not going to have equal slopes. Okay, so here's our task for today. Write the equation of a line that passes through the given point and parallel to the given line, to the given line. Okay. So write the equation of a line that passes through the given point and parallel to the given line. Okay. So let me get the rest of my stuff here. Let's start off with something like this. So I'm going to give you a point, a coordinate. And so I want a line that goes through this point and is going to pass through this line. Y equals 3/4 x minus 5. I want it to go through this line. Go through this point, but it's going to be parallel to this line. So I want us to think, how can we do that? I want to come up with a new equation for my other line. Again, goes through this point, and it's going to be parallel to this line. Yes, Jaime.
You can change the
The what?
The minus 5.
Minus 5? What do I want to change?
Maybe it's like.
But how will I make sure that if I change it, how will it? Okay, let's take a step back. I like what you're doing initially because my other line, my new line that goes through this point, has to have a slope of what? It has to have a slope of 3 over 4. So it's going to be y equals 3/4 x plus or minus something, right? We know it shouldn't be 5. So let's start with that fact. The slope for our new line has to be what? 3 over 4. So we have a slope, we have a point. Is that enough information to write the equation of a line? Yeah, it is. Let's do it. So to answer this, we're going to do the following. We're going to say, okay, we need a slope. Usually I like symbols. The slope of the line parallel to my new line has to be 3 over 4. Basically, it has to be identical to this one. It has to be 3/4. So just my new point has to be 3/4. And I have to use the coordinates -8, 3 because it has to go through that. Okay? Now, why don't we use, well, we have a couple of choices. We could use slope intercept, figure out what B is, and then plug it in, or we can use point slope and plug the stuff into point slope and solve it. Which way should we try? Let's do point slope. I prefer it. So we're going to use this point. This is going to be our x1 and y1. And this is going to be our slope. Let's plug it into point slope. So y minus 3 equals 3/4 x plus 8. We're going to plug it into point slope with that point that we need to have it go through and the slope. Okay? Let's solve it. Let's distribute. Y minus 3 equals 3/4 x. And then we got to multiply this. That's going to be what, 6? And then let's get rid of this minus 3. And boom, there it is. Y equals 3/4 x plus 9. And just like that, we have the equation that we're looking for. So it's guaranteed that this line, when graphed, will be parallel to that one, and it's going to go through this point. Okay? Any questions? So that was pretty easy, right? All right, let's just do maybe 1 or 2 more. Yes?
For these, can you also just like give any other points with the same slope?
Any other points with the same slope? Yeah. There's no guarantee that it's going to go through this. You see what I'm saying? That's the two requirements. It has to be parallel to this line, yeah, but it has to go through this particular point.
Oh.
Okay. If I go back into Desmos and graph them, you'll see that this one goes through that point. Hmm? Well, it has to go exactly through it. Yeah. Here, let's just take, watch. Let me do it really quickly. It takes, so we want 3/4 x minus 5. So let's do 3/4 x minus 5. There's one line. And 3/4 x plus 9. Okay, I gotta zoom out a little bit. And we want it, we're looking at the point negative 8,3. Negative 8,3. There's negative 8 right there. And 3. Let's see. 5, 6, 7, 8. 1, 2, 3. Right there. You see where my cursor is? That's negative 8,3. And it's through that point. So that's the two requirements, and we were able to do it. Okay? Any questions? All right. So let's say we have this. This will be number 2. Let's say I give you this point, 5, negative 2. And it has to go through this particular linear equation. So it has to go through 5, negative 2, and it has to be parallel to this equation, this linear equation. What's different here that we didn't have to worry about in the first one? Yes? Yeah. So the coordinates are a little different. How about the linear equations? Hmm?
Oh, it doesn't have a number.
Yeah.
A fraction.
The slope specifically, right? Do we know the slope for this one just by looking at it? Hmm? Well, it's not in the form that tells that I can see right away that the slope is there. Yes.
Is it 1?
Well, what makes you say it's 1? You're close. I want to say 1, but what format is this in? What do we call this form? Slope intercept form, right? This is in slope intercept form. This is in standard form. So we really, maybe you can't see it. It's a number close to 1, associated with 1, but it's not there.
Okay.
So this second equation is not in slope intercept form. So I don't know the slope, obviously. So guess what? We got to do a little rewriting. I got to solve for y. I got to get y by itself. In other words, I got to do this. And now my equation is y equals negative x plus 5. This is in slope intercept form. So guess what? Now I know the slope of this line. It's not 1, it's actually negative 1. So unless the equation is in slope intercept form, I won't obviously know the slope. Now I know it's negative 1. So now I can take it and run with it. I know the slope of the parallel line is negative 1. I have a point. I have the slope I want, negative 1. We can plug it in. Now we can do what we did before. So let's do y, what's it going to be, plus 2? Equals negative 1, parentheses, x minus 5. Okay, so we had to go that little extra step, rewrite it in slope-intercept form in order to be able to get to this point. Okay, so let's go ahead and distribute and do all of that stuff. Y plus 2 equals negative x, or negative 1x if you want, plus 5. We'll get rid of this. And I get y equals negative x, or negative 1x, plus 3. So here is the equation of a line going through 5, negative 2, and parallel to x plus y equals 5. Okay. All right. Let's do another one here. You guys ready? Okay. So let's do this one. We're going to go through number 3. So the equation is 3x plus 5y equals 30. And we wanted to go through the point 5, 3. Okay. So we want it to be parallel to this and going through that point. So let's start off with the fact that we don't know the slope of, it's not obvious what the slope is. So let's solve for y. Let's get y by itself. What's my first move? First, we want to get rid of the x term, remember? You want to get rid of the x term completely, so I'll do minus 3x on both sides. And then just bring down 5y. And on the other side, bring down, just write down those two terms, negative 3x plus 30. So now I don't want y, I don't want 5, I want y by itself. Divide by 5. But you got to divide everywhere by 5. Okay? And I get y equals negative 3/5 x plus 6. Okay? So now I know the slope. It's got to be negative 3/5. Okay? So I need a slope of negative 3/5 and the point 5,3. So let's run with that. We got m parallel should be equal to that, so negative 3/5. Okay, has to be equal. So use this slope, use that point. Let's plug it in. Y minus 3 equals negative 3/5 parentheses x minus 5. Okay? So now we do the same thing. Solve for y here. You're going to do y minus 3 equals negative 3/5 times x. And then negative times negative is positive. And what's 3/5 times 5? 3. 5 divides into 5 once. Then that 1 times 3 is 3. And add this 3. And here is our final answer. Y equals negative 3/5 x plus 6. Yeah, it's identical. What are the chances? Okay. So we're basically going to practice this. This is about as hard as it gets, to be honest. Where you have to take the equation in standard form, rewrite it in slope-intercept form so you know the slope, and then take the slope, take the point, plug it into point slope, and then solve that. Okay? That's the whole process. Any questions? All right, so we're going to go on to delta math. So go ahead and get your Chromebooks out now. And we're gonna practice 3 together in there, and then I'll cut you loose, okay? All right.